Better days are ahead. Today's lesson is on ratios and proportions. It's going to be real quick. It's not too bad. Ratios and proportions are one of the first things you learn in algebra and geometry to kind of tie things together. First, we're going to look at ratios. Then we're going to look at solving a couple ratio problems and look at proportions and solving a couple proportion problems. First off, ratios. Basically, the definition of a ratio is if A and B are two quantities that are measured in the same units, and that is extremely important, that same units thing right there. Because they have to be the same units. In the example, you might have feet and inches, and you have to convert everything to inches or convert everything to feet. You can't compare two things unless they are the same in the same unit. And if they are the same unit, then the ratio of A to B is A over B. You can see it written as that type of fraction, or you might see it as written like A over B. Sorry, my A's look like 9, so I've been working on that. So A over B. The ratio can also be expressed as A to B with that little colon in the middle. So because a ratio is a quotient, the denominator cannot be 0. So you cannot have your B be 0 in this case. And ratios are usually expressed in simplest form. Example, I might have a ratio, if I'm talking about a real word problem, I might have a ratio that would say something like, 6 to 8 or 6 to 8. But instead of expressing it like this, I would express it as 3 to 4. And so you're going to simplify your ratios just like you would simplify fractions. So let's look at a couple examples of ratios. First example, we have a rectangle. So the perimeter of a rectangle is 84 centimeters. So I know that right off the bat. I'm going to write that down. Perimeter equals 84. That's probably going to be important. The ratio of length to width is 5 to 2. Find the length and the width of the rectangle. So I'm just going to go ahead and label. It says length to width is 5 to 2. So the length is the long side. So I'm going to label this side down here length and label this width. And we're going to figure out what is the actual length and width of this rectangle given that the perimeter is 84. Well, if my ratio is 5 to 2, that means for every 5 units of length that I have 2 units of width. So I can actually write that using a variable. So I can say that L is going to be 5x and W I can represent as 2x because 5 to 2. Every 5 units I have of length, I have 2 units of width, and the unit in this case is x. So when we're finding the perimeter, we know that the perimeter is all of the sides add up together, and this is a rectangle, so that means opposite sides are congruent. So that means this length up here is also 5x, and this width over here is 2x. So in this case, I've got 2x, 5x, 2x, 5x. When I add all those together, I get 14x, and 14x is going to equal the perimeter, which is 84. And now you solve for x, so you're going to divide both sides by 14, and you get your answer, x equals 6. So x equals 6 is my answer for this problem, but it's not what the word problem is asking me. It's asking me what is the length and width of the rectangle. So to find the length and width, we would take 6 and plug that back in. So we're going to change, instead of x, we're going to write 6. So we'd say the width of the rectangle equals 2 times 6. So that's 12, and the length of the rectangle equals 5 times 6, so that is 30. And there's your ratio of 5 to 2. And you can actually write this as 30 to 12, and you can see that that would actually simplify to 5 over 2 if you were simplifying that ratio. But this is our actual word problem answer because this gives us a representation of what we're talking about. 30 centimeters, I should say. Left off units there. 30 centimeters to 12 centimeters. That is the ratio of the length and width of our rectangle. Let's go on to another example. A little bit different example using ratios. So in this case, I've got the ratio of the side lengths of 2 triangles are 3 to 1. Find the unknown lengths. So I know the ratio is 3 to 1. That's important. And I want to assume that this triangle is bigger. Usually when they give you these types of word problems, you can look at the figure and figure out which one's the 3 and which one's the 1. So this, I'm going to write 3 in here and I'm going to write 1 in here. So this is 3 to 1. So to get from the bigger triangle to the smaller triangle, I'm going to divide by 3. To get from the smaller triangle to the bigger triangle, I'm going to multiply by 3. That's the 3-to-1 ratio. So we can just fill in these values real quick just by multiplying and dividing by 3. So if I multiply 2 by 3, I get 6. So this side is 6. If I divide 12 by 3, I get 4. So there are my two side lengths. And I don't have either one of the hypotenuse, so I have to use the Pythagorean theorem. Now I have to use the Pythagorean theorem once, because if I find the side of length of one side using the Pythagorean theorem, I can divide or multiply by 3 to get the other. So I'm going to actually use a smaller triangle because it's going to be easier to work with, and then take my answer and multiply it times 3. So I can actually label this as x, and I can label this as 3x. So once I find out what x is, I can just multiply by 3 to get the bigger hypotenuse. So let's figure this out. So Pythagorean theorem is a squared plus b squared equals c squared, or side squared plus side squared equals hypotenuse squared. So we've got 2 squared plus 4 squared equals x squared. 2 squared is 4. 4 squared is 16. So that equals x squared. So this is 20 equals x squared. So x is going to equal the square root of 20 when I take the square root of both sides. So x equals the square root of 20. And this can be simplified. We can simplify radicals. But we're just going to leave it as a square root of 20. And then we're going to triple that actually. So if x is square root of 20, then that means 3x would equal just 3 times the square root of 20. And you can write this as a decimal. You can simplify radicals. We haven't really learned how to simplify radicals yet, so I'm going to leave it as square root of 20, and you can figure what that is in your calculator. But it's actually easier just to multiply times 3. So I know now that if this side is 3, I'm sorry, if this side is x, then this is going to be the square root of 20. And if this over here is 3 times that, this is just going to be 3 times the square root of 20. And there's your lengths. That's ratios. The next thing is proportions. So as we move on to proportions, if I'm going too fast, remember you can always pause the video, go back, write down an example. If you need to look over something again, you can do that. That's the beauty of these videos. But as we move on to proportions, we're looking at the definition of that. So an equation that equates, it sounds weird, but it is true. An equation that equates two ratios is called a proportion. Usually these problems are solved using cross multiplication. You will always be given 3 pieces of information in this proportion. You'll have to find the 4th. So usually you're going to cross multiply. There are tricks so you can solve them faster. And as we do more examples, I'll show you that. But as it is right here, we got 2 examples. The first one is just, it's already given you the proportion. This may have came from a word problem, may have came from something you had to set up. But it gave you the proportion. You just have to solve for x. So the whole cross-multiplying theorem, or whatever you want to call it, it comes from the fact that you can multiply both sides and then divide. That's what cross-multiplying is. So cross-multiplying says I can multiply the diagonals. So this would multiply the diagonals, give me 10x equals 72. And this is just a shortcut, because by multiplying the diagonals, what I've done, technically, is I've multiplied both sides by 8. Let me do this off to the side so you can see it. If I have x over 8 equals 9 over 10. Technically what I've done is I've multiplied both sides by 8. That gave me x equals 98. Sorry, 90. Obviously I've never multiplied before. 72 over 10. And in this case actually cross multiplying was longer, but this is how it works. So we cross multiplied, we got x equals 72 over 10. This is what we're going to get eventually if you cross multiply and divide. If we divide both sides by 10, you get x equals 72 over 10, just 7.2. So either way, you're going to end up with the same answer. Sometimes it is faster just to multiply by the denominator, but if your x is actually in the denominator, it gets a little bit trickier. But either way, you see the answer is 7.2, no matter which way you go about this. There is more than one way to solve a proportion, and there might be a faster way, but no one way is more correct. Whatever way you're more comfortable with getting to the answer, that's the way you should use. This is just a basic example of how you would cross multiply, or how you would simplify the fraction by multiplying both sides by 8 to get those 8s to cancel to 1. So you're left with x on the other side. All right, last example, and this is going to be, we have two triangles. Actually, yeah, we have two triangles, and we're given a statement, and we're going to use this proportion that we're given, this statement, to solve for the missing side. So here we have two triangles. We have triangle ABC, and we have triangle ADE. So there's two triangles, and then we have basically have a smaller triangle inside of the bigger triangle. And this proportion is telling me they have, a relationship. These sides have a specific relationship. So if you look at this, it says AB is congruent to BD. So if you look, or not, I'm sorry, not congruent. AB is a ratio to BD. We don't know what that ratio is, but it is a ratio. So there is some ratio between AB and BD. So we're looking at those two sides, and those sides go with AC over here and CE. So when we look at these, we're going to set the ratio just like it is. So we're literally going to take the actual points, or the segment AB, and plug in what our value is, and segment BD and plug in what our value is. So segment AB equals 18. So I'm going to write 18 over segment BD, which is 6, equals segment AC, which I don't know, so I'm going to call that X. You could also write AC if you wanted to instead of using X. X over CE, which is 3. All right, now I'm going to cross multiply. You can solve whichever way you want to do it. I'm just going to multiply both sides by 3. And these 3's are going to cancel to 1, so it's going to leave me with X. And then instead of doing 3 times 18 divided by 6, there's a shortcut you can do here. You can simplify the 3 and the 6. So I can say, well, 3 divided by 3 is 1, and 6 divided by 3 is 2. And you can simplify that fraction before you multiply, and it just makes things much easier. So now I have 18 divided by 2. 18 divided by 2 is 9. And again, you can see 2 divided by 2 is 1. 18 divided by 2 is 9. So your answer is 9. So X equals 9 is your answer. And as you can see, the ratio, it makes sense because over here on the DB side, we went from 6 to 18. So we multiplied by 3. Over here, we went from 3 to 9, multiplied by 3. So that is the ratio. The ratio of DB to BA is 1 to 3, or vice versa. AB to BD is 3 to 1. So you can look at it either way. It's not asking you for the ratio, but I'm just showing you that's where it came from. All right, if you have any questions, you can put comments. If I have any mistake, let me know. It happens. Other than that, we'll work out some problems in class.
My intuition is telling me there'll be better days. I sit in silence and find whenever I meditate, my fears alleviate, my tears evaporate, my faith don't deviate, ideas don't have a date.